Hi, this is VBL. In the previous video, we got to know about what you mean by number system, significance of number system, evolution of number system and the types of number system. In this particular video, you will be getting how to represent number systems and the conversion techniques between decimal number system to any other number system and vice versa. Let's get into the topic. Number can be represented by two parts, integer part and fractional part. These two parts are separated by a point. That point we call it as base point or radix point. Radix value or base value, which is nothing but the number of digits present in a set related to the number system. For example, if you take a decimal number system, the set contains 0 to 9. That means 10 various digits. So that will become your radix value. So this can be represented as alphabet D. And then in binary number system, there are two various digits. So the radix value will become 2. This can also be represented by alphabet B. And then octal number system, which contains 0 to 7, totally 8 various digits. So that will become the radix value of octal number system, that can be represented by alphabet O. Hexadecimal number system, which has got 0 to 9 and A to F, totally 16 various digits. So this will become radix value. This can also be represented as H. As we know, in positional number system, each digit value depends on its position relative to number system. Let's take an example of decimal number 345.12. 345 is integer part and 12 is a fractional part of this number. These two numbers are separated by a point. That point we call it as radix point. The first position here, we call this as a unit position, and then 4 is in 10th position, 3 is in 100th position. Similarly, when you consider fractional part, 1 is in 1 by 10th position, 2 is in 1 by 100th position. These things can be written in terms of radix value. 1 can be written as 10 power 0, which is nothing but 1, right? And then 10 can be written as 10 power 1 and 100 can be written as 10 power 2. Here 1 by 10 can be written as 10 power minus 1 and 1 by 100 can be written as 10 to the power of minus 2, right? So now if you observe this, you can see here each position value is represented by multiplying 10 to the previous position value. 10 power 0 is nothing but 1. 1 into 10, you will be getting 10. 10 power 1. When you multiply 10 with this 10 to the power of 1, you will be getting 10 power 2. This happens in case of integer part. When you consider fractional part, here each position value which will be divided by 10. See, here you will be getting 1 by 10 is equal to 10 to the power of minus 1. So this is divided by again 10, you will be getting 10 power minus 2. If you divide this by again 10, you will be getting the next position value as 10 power minus 3. So now I can write the number by considering the position value like this. 5 is in unit position, that can be represented by a radix value 10 power 0. 5 into 10 power 0 is the value of this digit. 4 is multiplied by the radix position value 10 power 1. So this will be equals to 40. Similarly for 3 multiplied by the position value 10 power 2, which will be equals to 300. So when you sum all these integer value, you will be getting 345. Similarly you can do for the fractional part. Fractional part, this position, that is 1 by 10th position, 1 divided by 10 is nothing but 0.1, and then here 2 divided by 100 is nothing but 0.02. So when you add these two, you will be getting 0.12. So you can represent by taking the position value of that number system with the coefficient. You will be getting a generalized formula by taking this as an example. I can write this 10 power 0, which is nothing but radix value of the decimal number system. So I am generalizing that as a radix value r here, r to the power of 0. Since it is related to this unit position digit value, so this is taken as coefficient a0. Similarly, the next coefficient as a1, r to the power of 1, and next position is a2, r to the power of 2, and it goes on till nth position. When you consider fractional part, here you will be writing the radix value here represented as r to the power of minus 1. Since it is written as minus 1, I am writing the coefficient as a minus 1 here, and then the next value is a minus 2 r to the power of minus 2. It goes on till the mth value. So this is what the generalized expression for positional number system. Hope you understood how to represent general expression for positional number system. Now let's move on to the conversion techniques. Here we are converting any other number system to decimal and vice versa. If you are converting any other number system to decimal, you need to remember a hint here is use general expression. You write the general expression before you convert any other number system to decimal. Let us take an example. Binary to decimal conversion here. 101.11 is the binary number. I need to convert this to a decimal value. So for that I need to use general expression, right? So now use this general expression. It is saying that coefficient of unit position is multiplied by the radix to the power of 0. What is the radix value of this binary number? You know that it is 2. So that I can write this unit position is multiplied by radix value 2 to the power of 0. The next digit is 0 multiplied by 2 to the power of 1, similar to a1 r to the power of 1. And then 1 here is multiplied by 2 to the power of 2, which is similar to a2 into r to the power of 2. When you consider this fractional part, 1 into r to the power of minus 1. Here r is 2, so that 2 to the power of minus 1. The next digit is 1. 1 multiplied by 2 to the power of minus 2. You know that 1 divided by 4 is nothing but 0.25. 1 by 2 is nothing but 0.5. 1 into 1 is nothing but 1. 0 into 2 is 0. 1 into 4 is 4. When you add all these things, you will be getting 5.75, which is the equivalent of 101.11. So this is the conversion technique for binary to decimal. Let's convert octal to decimal. When you are converting octal to decimal, the same hint. Use general expression for converting octal to decimal number system. Here I have taken 42.13 octal number. I need to find out a decimal value for this. So use general expression. As you know, this is the unit position a naught multiplied by radix to the power of 0. That is what I have written. 2 into 8 to the power of 0. Radix value is 8 here. So that 2 into 8 to the power of 0. And then 4 into 8 power 1. Similarly for this fractional value, 1 into 8 power minus 1. 3 into 8 to the power of minus 2. So when you solve this, you will be getting the value 34.1718, which will be the decimal value equivalent to 42.13. Next, we'll convert hexadecimal number system to decimal number system. Here, we need to use a hint, general expression. By using general expression, we can convert hexadecimal number system to decimal number system. As we know that this a0 represents the digit in the unit position that I have written here. E into base value, that is 16 to the power of 0, plus C into 16 power 1, A into 16 power 2, F into 16 power 3. And for fractional part, 6 into 16 to the power of minus 1, 9 into 16 to the power of minus 2. So here you need to represent this F equivalent value is 15 and A equivalent value is 10, C is equal to 12, E is equal to 14. All those things you need to represent here, and then you need to have multiplication. When you multiply all these things and add, you will be getting 64,206.41015. This is the equivalent of this FACE.69 hexadecimal number. When you want to convert any other number system to decimal number system, the hint is you need to use general expression. Now we are going to convert decimal number system to all other number systems such as binary, octal and hexadecimal. Let us take the first type, decimal to binary. Here what you need to do, you need to take the integer part of the number divide that by base and then collect the remainder by bottom up manner. This is the hint for converting integer part of the decimal number. And then when you take the fractional part must be multiplied by the base value and collect all the integer part of that answer in a top down manner to get the fractional equivalent. Let us take an example here. 26.4375 is a decimal number here. I need to convert this into a binary number. So from the hint, what I can do here, I need to take the first part, that is I have represented here it as P1. So P1 hint is divide the integer by base. So I have taken 26 is an integer part, as you know. This integer part is divided by the base value, that is 2. So 2 ones are 2 and 2 3s are 6. So there is no remainder, so I can write 0 here. Again divide by 2. 2 6 are 12, 1 remainder I have written here. 2 3s are 6, 0 remainder. 2 1s are 2, 1 remainder. Now what you need to do? You need to take the answer from bottom up manner. 1 1 0 1 0, that is the integer equivalent. Next part 2, here I have taken 4375. 0.4375 I need to multiply by 2. The second part of the hint says that fractional part must be multiplied by the base value. That I have done here. 0.4375 is multiplied by 2 and the answer is 0.875. And again take the fractional part. Don't take the integer part here. Only take the fractional part for the further multiplication. So here 0.875 is the fractional part, multiplied by 2 to get the answer 1.75. Here what you need to do? You need to take only fractional part for the next multiplication. You need to leave this integer value. So I have taken 0.75 multiplied by 2. You will be getting 1.5. Again multiply the fractional part here. 0.5 into 2, you will be getting 1.0. Now further multiplication cannot be done because the fractional part is 0 here. Now what you need to do? You need to collect all the integer part of this answers. So here 0 1 1 1 is the answer, because here you need to take the answer from top to bottom manner, so that the part 2 will be giving you 0.0111. So combine these two, you will be getting the converted value for binary. See here, the part 1 says that 1 1 1 1 0 1 0 point, the fractional value here 0 1 1 1. This is the converted value from binary, from decimal to binary. Convert decimal number system to octal number system. Here I have taken 283.728 as a decimal number. I need to convert this into octal number system. So we need to remember these two hints. So integer part is divided by base value and the answer is taken from bottom up manner, and then fractional part is multiplied by base value and the integer part of all the answers will be taken from top to bottom manner. So now let us take the integer part here, 283. So 835 is the 280, you will be getting 3 remainder, and 8 4 is a 32, you will be getting 3 remainder. Further division cannot be done, so that now I need to take the answer from bottom up manner. 433 is the integer equivalent. You take the fractional part here, 0.728, that is multiplied by 8 to get 5.824, and now take the fractional part again, 0.824 multiplied by 8, you will be getting 6.592. Take the fractional part 0.592 into 8, you will be getting 4.736. Take again the fractional part 0.736 into 8, you will be getting 5.888. So this goes on. So what you need to do? You need to stop this multiplication for 4 variables, 4 values. So it will be specified in your question itself. If it is specified for 6 values, you need to continue this for 2 more values. If it is for 4 values, you can just keep this for 4 multiplication and take the integer part from top down manner, so that you will be getting P2 is equal to 0.5645, so that your fractional part conversion is over and integer part conversion is over. Combine these two, you will be getting 433.5645. This is what the octal value, which is equal to 283.728. Let's convert decimal number system to hexadecimal number system. Here I have taken the decimal value as 843.10546875. So this must be converted into hexadecimal number system. Means you need to remember the two hints here. Integer part is divided by base, and then the answer is taken from bottom up manner, and fractional part is multiplied by the base value, and the integer part of the own answers are taken from top to bottom manner. So let's take the integer part. 843 which is divided by 16. 16 5s are 80, 43 is remaining. So 16 2s are 32, 11 is remaining. So 11 can be written as B in case of hexadecimal number system. And then 16 3s are 48, 4 is remaining. So further division is not possible. So answer is 34B, that I have taken here as part 1. Part 2, I have taken 105.46875 multiplied by 16, which gives 1.6875. Now I need to take only the fractional part for further multiplication. So take that fractional part, 0.6875 multiplied by 16, which gives you 11.00. As you know, in case of hexadecimal, you need to take after 9, you need to write alphabets A, B, C, D, E, F, right? So this 11 indicates B alphabet. You need to represent that here. So the answer is, you need to take from top down manner. So 1B is the answer. Point 1B is the part 2 answer. Now combine part 1 and part 2 answer to get the hexadecimal value. The part 1 answer is 34B. 34B point, the fractional conversion value is 1B. So this is what your hexadecimal value, which is equivalent to the decimal value represented here. On the whole, what I can say is, you can use general expression for converting any other number system to decimal number system. If you are converting decimal number system to any other number system, you need to use these two hints. Integer is divided by base and the data is collected from bottom up manner, and fractional part is converted by multiplying it with the base, and the data answer is connected from top down manner. That's all for this video. Hope you like this video. Kindly like, share, comment and subscribe for more videos, and press on bell icon to get upload notifications. Thank you.